The broadcast is now starting. All attendees are in listen-only mode.
Okay, I think we've given a couple extra minutes for everybody to show up here, so we'll go ahead and get started. And here we go. All right, for everybody who doesn't know, my name is Bill Jones. I'm a applications engineer with SolidExperts, and I am going to go over our webinar today, which is our favorite new features in SolidWorks Plastics 2015. So let's go ahead and kick this off and see where we go from here. Real quick, we're going to start with a quick overview of all the different simulation products. There seems to be a little bit of confusion since we've done a number of different additions to the family here. Quick overview of simulation tools. We have the FEA tool, simulation for static, dynamic, thermal, frequency, those types of problems. Structural simulation tools. We have the motion simulation tool, which handles the kinematic and interaction problems. Flow simulation is the full-featured computational fluid dynamics package. Sustainability, which can analyze the impact of your product on a global scale. And finally, added to the family just a couple years ago, is the plastic simulation package, which makes it easy to design plastic parts for injection molding and optimize those designs for manufacturability. This year, SolidWorks has done a complete overhaul of all of their product branding, which will be most obvious in the naming levels of the products. I'll get to that in a slide further down the road here. And in addition to SolidWorks Plastics, is changing from the 2014 add-on model to kind of a standalone model. So it will need its own serial number versus being tied to your existing SolidWorks serial number. So the SolidWorks Plastics packages, let's describe these a little bit because there has been some changes this year in particular. And we're going to start off with Plastic Standard. So Plastic Standard is the basic package. It's targeted towards plastics part designers for the use during the design phase of a product's life cycle. It's CAD integrated, fully embedded into SolidWorks 3D design environment, so you can analyze and modify designs for manufacturability while you optimize it for, triple F, form and function. Okay, and that's pretty much what the standard package does for you. It's for the end user to kind of mess with the parts, make sure they're worthwhile to make as a plastic part. The next level is Plastics Professional. This gives designers or builders of injection molds the accurate and easy way to optimize them. You're able to quickly create and analyze single, multi-cavity, family mold layouts, avoid costly mold rework, ensure molds will work right the first time, avoid time-consuming, costly, unnecessary rework. Optimize feed system design. You can analyze sprues, runners, gates, balanced runner systems, optimize gate type, size, location, and determine the best runner layout, size, cross-sectional shape, etc. You can also estimate the cycle time, clamp tonnage, shot size, quote tooling projects quickly and accurately, size the injection molding machine for a given mold, optimize your cycle time, and reduce your plastic material scrap. So you get a lot of extra tools in Professional from Standard. And lastly, we have added to the family now, we have Plastics Premium. Plastics Premium includes everything that comes in Professional, plus it has advanced simulation functionality that allows users to analyze mold cooling, line layouts, and predict part warpage. The cooling line analysis, design and analyze simple or complex mold cooling line layouts, reduce time and cost by optimizing cooling system designs to minimize cycle times and decrease the manufacturing costs, and improve overall process, optimize the part and the mold design, the material selections, processing parameters, anything we can do to try and reduce or eliminate mold warpage so that we make sure that we're going to make a good part every single time. Okay, so let's get into what's going to be our actual top 5 favorite new features. So without further ado, number 5. Number 5 is going to be e-drawing support. Anyone with SolidWorks Plastics can now dump out their information into e-drawings. This allows any customer, supplier, coworker to view the design without needing SolidWorks or Plastics. This will allow for better collaboration between teams, organizations, vendors, customers. E-drawings will Also allows you to do the normal e-drawings things. It allows you to do markups, take notes, point to features in the model, and it's just a really great tool to allow teams to communicate more accurately dealing with the plastics data without having to have everybody buy plastics, right? And just to kind of show you what that looks like, create a quick little demo here, and we'll go ahead and show that real quick. And basically, this is a plastics part brought up in e-drawings, and zooming in here to kind of show the detail that you do get inside of e-drawings. And you also have the ability to turn on the legend, and you also can see the scale on the legend there, and you can also turn on the title of this so you can get more information about the model itself. So very similar to what we have in simulation results in e-drawings, but now brought that over into plastics so we can actually get a good view of that and send that out to a customer, vendor, somebody else on the team that doesn't have plastics. Okay. So number 5 was e-drawings, integration with e-drawings for plastics. And now let's go to number 4. Number 4 is going to be the nominal wall thickness advisor. This is a new capability in 2015 that everybody gets. So all levels of plastics, which is standard, professional, and premium, you're able to view wall thickness of your part relative to the nominal value. So this is displayed as a percentage difference from the nominal, right? So what we're looking for is, in a case of like this screenshot here, the design intent on this is that you want to make sure that you have a uniform mold thickness, right? So if the part's supposed to be 2 millimeters thick, then the designer should try to make the whole thing 2 millimeters thick. Otherwise, you can have variations that can cause defects, production issues, things of that nature. Parts with uniform wall thickness are also optimized for cycle times. They're less likely to warp or deform. And in this particular case here, we can also change our display and switch it to overall thickness distribution so that we can see a more detailed feedback. Okay, this is a very useful capability for identifying potential bottlenecks in the injection process. So again, this screenshot's kind of nice, but let's go ahead and show you a real quick video of this, video that I recorded of actually doing this. So basically this is in the advisor here, this is a nominal wall thickness. It's kind of like your simulation results, right? So we're going to go ahead and open up the advisor here. And here we can kind of see the color variances between this for the nominal wall thickness. So right now we're showing it by percentage, and what we're doing is we've set it for 2 millimeters. And of 2 millimeters, we can see areas where we're plus or minus 30% of that 2 millimeters and plus or minus 20% denoted by the different colors here. So the cool part about this is I can actually change this value, change it over to 3. So now I can see what my values are. If I change that to if I wanted a 3 millimeter part, I can see that a lot of this part would not meet 3 millimeter nominal thickness. Okay, and I can go ahead and change that to 2.5. And if I wanted to, I could also change it for the value itself. So there's a number of different ways that I can interpret the data here, and that will give me what my nominal wall thickness would be on this part. So that's one of our nice new features in 2015 that was just added, so this was really cool. Number 3, symmetrical mold cavities. This is actually a really cool feature. Analyzing models with symmetry is a lot easier with Plastics 2015. We now support for runner symmetry, which we didn't do before, so that you can validate the injection process in a fraction of the time. This new feature is only offered in professional and premium. Standard people don't get this. And again, mostly because this is geared more towards a mold designer, mold maker, not somebody who's just analyzing the end part by itself, right? So as we look at this here, as we're going through the mesh settings, it's now possible to define a single runner setup or specify that it's symmetric. After creating the mesh, we have the ability to specify the symmetry, whether it's half symmetric, quarter symmetric, or contains circular symmetry, and then we can set the different values for what we want that symmetry to be. So 1, 2, 3, 4, or 5, whatever the case may be. The final mesh shows the sprue and runner are meshed as a wedge for symmetrical boundaries, and that enables the model to just a portion of the structure and get the same results in a faster time with the same accuracy in the results. And so let's go ahead and do one of these. just to show you. So inside of our plastics here, we're going to go ahead and do a manual mesh on this. We'll do a solid mesh, and we're going to go ahead and do a runner and cooling system design. So this is basically just a layout sketch that gets created. We have to create this, but this is a layout sketch that we create to put this in. And from here, we can now set up some of our parameters. So we're going to do a cooling channel here. We're going to go ahead and kind of click through this real quick. Some of this I've got set up already. And in here, we're going to turn on our mesh, get our mesh going. There's our summary of the mesh. And now what we're going to do is come in here, and we're going to turn on set the symmetrical runner, right? So we set that. The first one's going to be half symmetry. We also have quarter symmetry, circular symmetry. And then if we do quarter symmetry, we got the 4. If we do circular symmetry, it takes us to the 2 iteration. And just like anything in SolidWorks with the instances, we can go ahead and use the either type in a number or use the up and down arrows so that we can get our end result here of circular symmetry for 5 different units. So again, symmetry, another nice cool feature. Again, it's only for professional and premium level products. Number 2, venting analysis. This is actually a really cool one. When the mold closes, there's a cavity, of course, in the shape of the actual part. But before it gets filled with plastics, it's also filled with air. And the air has to go somewhere as we're pressing all this plastic in there. Up until now, plastic simulation has assumed ideal venting, that all the air is properly vented and taken out. With this new analysis, though, we can now assess how a part will fill based on improper venting, or where a vent should be added in order to ensure a quality part. Buildup of gas in the mold can lead to a surface blemish, imperfections, just all kinds of problems with the end part. There is a new results category for this. It gets, all these analyses are run when you actually run the solver, and then now it's just a category that just gets shown up. So in this case here, it allows us to view the venting pressures over the part, and the results of this help us identify parts where it may be advisable to add an air vent, or and anything that we can do to try and minimize the potential problem of gas buildup. Okay. So what I'm going to do here is I'm going to show you an analysis that was done, of the venting analysis that was done before adding any, before doing vents in the actual model itself. So with the venting analysis, I'm able to see that as far as the solver is concerned, there's a lot of pressure built up at all the fin ends, right? So there's a lot of pressure there, and it's still even, as it's, suggesting that there's ideal venting, it's still got a lot of pressure at the ends, okay? So if we do this, now let's run this after we've added some vents to it. Now we can see the difference in the model. So in the model here, we can see that we don't have the pressures at the ends. We have it at specific points, a little more what we would have expected to have seen, right? So let's kind of run through this. I'll walk you through this real quick. So on here, what I'm going to do is I'm going to pick on venting pressure, and I'm going to see where my pressures are. And in this case, I've got pressures right at the edges. So this is based on that last model. And now what I can do, knowing the venting pressures, I can actually go into the model. I've got another one here that's already completed. And let's go back to plastics here. And here I've added some air vents. So I'm going to go ahead and I'm going to check what these look like. Now notice the red dots on the 4 corners there. And I also left 2 of them that don't have any pressure relief on it. So we can see the difference between what happens when I do allow venting and where I don't put the venting, right? So by adding these vent locations, now I can go back, take a look at the study. And as I look at the flow results, and I'll check on the venting pressure, now I can see how much lower the pressures are at those 4 corners where I added the venting, and they're still high in the 2 where I did not add venting. So I may want to add additional venting. I may want to, figure out something else. But now I can actually see that information, see that data, and start to figure out, what I need to do to make a better part. And our number 1 new feature that we like about SolidWorks Plastics in 2015 brand new mesh algorithm. Right now we have a non-orthogonal voxel mesh is our new meshing algorithm for plastics. It will add more elements in areas which need it, and it will do this automatically. We don't have to do kind of like we do in structural, where we create mesh refinements or localized mesh settings. Okay, this is an adaptive form of meshing. We'll get an accurate representation of the geometry, along with a much faster solution time that we get with a hexagonal mesh. Right. This will improve our mesh quality and analysis results for more complex designs. So this is a example here of a regular voxel mesh. You can see that the fine features don't adequately get captured in this. Everything's like a brick. It's a very brick mesh, right? Many injection molded parts have very complex surfaces. I mean, that's most of the time why we're designing in plastics. We want to create organic shapes. We want to create swoopy things, lots of lofts, things like that. And this does not necessarily lend itself perfectly to what's going to happen to this model as we're making the actual part. So we miss the ability to capture critical areas. With the new non-orthogonal voxel mesh, that same part is now meshed in this manner. As you can see, the mesh has automatically been refined in the areas of high curvature or very small features. And also note that some of the elements are no longer brick-shaped. They're mapping themselves around to make the most sense of the geometry. So this is, again, a much nicer mesh, and will still give us very quick results without having to do a whole bunch of manual mesh refinements and things of that nature. So here's a detail of one of the ribs and the tabs, so you can get an idea of how this actually is working. You can clearly see, the much better refinement level that you're getting with this. And let's go ahead and we'll throw you through one of these. And basically what we're going to do is we're going to start a mesh. We'll create a manual mesh in this case. And we're just going to go ahead and create a mesh. There's a standard mesh. And what we're going to do is come through here. We're going to change this to a hexahedral mesh. And we'll see that here that we're going to select voxel. And we're going to go ahead and transform that. And now you see our token brick layout voxel mesh. Very fine, very detailed, but not necessarily the correct detail that we want. We're going to change this to a non-orthogonal, and we'll go ahead and transform this. Now we see those very nice, complete levels of detail for all the little sections that we really need to pay attention to. And if we go ahead and run a real quick flow study on this, and we'll go ahead and we'll animate that. So here we can see we get very nice detail. Look at the high contrast in the color gradients that are going through those fine detailed areas. And then we see the areas further out are they're not quite as detailed as the areas that we really need to pay close attention to. So again, these are our top 5 brand new features in 2015. And as far as the webinar goes, that's pretty much the core of the webinar. There's, again, 5 features that are new. There's a lot more going on inside of plastics. If there are any questions, I'll be more than happy to answer those at this time. And we'd just like to thank you for attending the webinar. Hopefully you got some good information. And again, if you have questions, I'll be more than happy to answer them. Or if you need more information, maybe not at this moment, please feel free to contact us, either call us, email us, just get in touch with us any way you need to. So I thank you for attending. SolidExperts thanks you for attending. And again, hopefully you got something useful out of this and learned some new stuff in 2015 plastics. I'll leave it open here for a few minutes and grab some questions. And if I don't have any questions, I'll go ahead and close this out in a few minutes, and we'll be all set. Thanks, guys and girls.